When you draw the mechanism for a reaction, you always need to make sure that you draw the correct curved arrows. Here are some of the rules that you can apply to draw the curved arrows. Here are a few do's and don'ts for drawing the curved arrows. So to begin with, this oxygen has got extra lone pairs of electrons, and it is trying to form a double bond here. As this bond is formed, carbon is going to have 5 bonds now. Now one of the bonds need to break. Out of the 4 bonds, which one is going to break? It is going to be the CBr bond, because that's the one that's going to be weak, right? So bromine is electronegative and it's going to take its lone pair of electrons and leave. So this is the right way of drawing the curved arrows. But you cannot simply put the bond between or shift the electrons between the carbon Br bond to the carbon oxygen single bond to make it a double bond. There's no driving force for this bond to break, and therefore this is incorrect. Whereas this one is right. Let's go on to the next conversion here. So when you have a base has the ability to grab this hydrogen. As this hydrogen is grabbed, these electrons can go on to neutralize the positive charge on oxygen. But this way, where the hydrogen is trying to take its lone pair of electrons and leave, it's not possible. The hydrogen cannot take its lone pair of electrons and leave. Let's go on to the next one. When you're trying to remove a hydrogen from here using a base, those electrons need to go on to the oxygen because it has got a positive charge on it. On this side, you have a hydrogen that is trying to take off from the molecule. This is not going to be possible. In order for removing the hydrogen, you need to have a base. A base needs to come and abstract the hydrogen, which is like grabbing the hydrogen, and only then this bond is going to break. The hydrogen cannot leave by itself. Incorrect way of drawing the curved arrows, whereas this one is right. Now in the next one, this is an hydroxide ion. The hydroxide ion is trying to make a nucleophilic attack on this electrophilic carbon. So this carbon right here is going to have a partial positive charge on it. So as this hydroxide ion is trying to form a bond with this carbon, there's going to be 5 bonds to this carbon. So one of the bonds need to break. It would be the pi bond that's going to break, and it's going to move towards that oxygen. Right? So this is the right way of drawing the curved arrow. But this one is wrong, where the first step is right, where the hydroxide ion is trying to come and attack this carbon. But when this bond breaks, it's not going to form another bond towards this oxygen. Instead, it's going to go on to the oxygen because oxygen is electronegative, and it's trying to take its electrons towards itself. This is basically the first step of the electrophilic addition reaction of an alkene, where the electrons from the double bond is going to go attack this hydrogen and thrust the electrons between the hydrogen and Br to go on to Br to form the bromine ion. So now it forms the carbocation. Why? Because this carbon has lost the double bond, and therefore it now has got only 3 bonds, and therefore it should have a positive charge. Now this way of drawing the arrows is completely wrong. While this is right, this one is wrong. Now why this is wrong? Because the arrow is starting from the atom. It doesn't really make any sense, right? Because the atoms cannot move. It's only the electrons that can move. So we have to start the arrow from the electrons to the atom. Okay. Here again, the arrow is starting from the electrons to the atom. Okay. So this is wrong. And this is the right way to draw this curved arrow.